Today we're going to look at an example of a chi-squared test for a variance or a standard deviation. I've got quite a few questions on week 2's homework because some of the problems ask you to use a program called SDHYP. I believe that's just a program that the publisher made up. It probably stands for Standard Deviation Hypothesis Test, but it's not a program you have on your calculator. So I'm going to go through an example of how to solve it with the programs that you have on your calculator. Our first step is going to be to read the problem and decode it. So a statistics professor is used to having a variance in his class grades of no more than 105. He feels that this current group of students is different, so he examines a random sample of midterm grades as shown, and at an alpha level of 0.10, can it be concluded that the variance in grades exceeds 105? Use this program, which we won't, but we will use a p-value method. So it says, right here it says the variance in the grades exceeds 105. So we're trying to see if we have enough evidence to conclude that the grades exceed, so strictly greater than 105. That's our claim. It has no equality in it, so we know it's going to go in our alternative hypothesis. So let's go ahead and write our hypotheses. Our null hypothesis, H0, and our alternative hypothesis, H1. Well, we know that we're testing a variance because it tells us a variance right here, and variance is denoted with sigma squared. The claim is that we want to see if we have enough evidence to support is the variance is greater than 105, so strictly greater than 105. The complement of that goes in our null hypothesis, so that the variance is less than or equal to 105. Now, Connect does not have an option for less than or equal to 105. They use another notation, which is just another way to write it. And instead of writing less than or equal to, they write strictly equal to. Either one is fine. Connect wants you to put equal to, but on your exams, either notation is fine. So step 1 is done. The next step we're asked to do is to identify our claim. Well, the claim is the professor wants to support is that the variance in his grades exceeds 105. So our claim is in our alternative hypothesis. Our alternative hypothesis has an inequality in it. It's a greater than sign, so it's a one-tailed test. So we have a one-tail test. Our next step is to enter all of our data, all of this data, into our calculator and get some descriptive statistics. So recall, to enter the data in your calculator, you're going to go to Stat, and then you're going to go to Edit, and then you're going to enter all of your data into List 1. After all of the data is entered, then you're going to go back to Stat, and this time you're going to go to Calculate. And what you want to calculate is 1 var, standing for one variable statistics. And you're going to get some descriptive statistics. And the things that we need right now for this problem is we're going to need to know our sample size, so n. Our sample size is 12. And we also need to know our sample standard deviation, so our SX. Our sample standard deviation, when I put this into my calculator, it was 14.1238971. Now, we don't want to round this. We always want to err on the side of more decimal places until we get to the final step. Because if we were just to enter 14.12, we would have a very large rounding error at the end. But the trick is our calculator, once we go to 1 var statistics, has stored all of that information in the calculator for us. So we can get back any of that information without any rounding. We can get the full number back. And to remind ourselves how to do that is we would go to vars on our calculator. It's vars. And then after we went to vars, we would go to option 5, which is, we'd go to option 5, which is statistics. And then we would pick the statistic that we want. And what I want is SX. Now, you don't have to do this, but this prevents you from having to, or makes it easier for you because you don't have to write down all these decimals. So SX. So far, we've decoded the problem, we've written our hypotheses, and we have our descriptive statistics. So now we're ready to find our test statistic. Our test statistic is a chi-squared we're going to use a chi-squared distribution. So we have a chi-squared test statistic. And that is equal to n minus 1 times SX, our sample standard deviation squared, all over sigma squared. And sigma squared is the value from our problem, which is 105. We have all this information, so let's go ahead and figure out what our value is. So n is 12, so I have 12 minus 1 minus, and then in my calculator, I'm just going to go var statistics SX, so that way I don't have to type in this long decimal. You could type in the long decimal if you want. Just make sure you include lots of decimal places so you don't have a rounding error. And then I'm going to put that over 105. Now I'm not going to square 105 because 105 is my variance, and sigma squared is the variance. So what I got in my calculator was 20.89837. So that's my test statistic. Now to find your p-value, remember the p-value is the area from your test statistic to the TEL. So just to remind yourself what the chi-squared distribution looks like. It looks something similar to this. So 20.89 would be, way over in the TEL, maybe somewhere over here. So let's say that's 20.89837. Our p-value is actually all of this area here in the TEL. So to find that, it's very similar to what we did for the normal distribution. When the normal distribution, we wanted to find the p-value, we used the normal CDF because we wanted to accumulate that area. Now, we don't have a normal distribution, we have a chi-squared distribution, but it's the same idea. We're going to use a chi-squared CDF. So we're going to go to distributions. So in our calculator, we're going to go to distributions, and then we're going to go to chi-squared CDF. And the chi-squared CDF has some parameters. What it wants is your lower limit, and my lower limit is the 20.89837. My upper limit, well, I'm going to go from this 20.89 all the way to infinity. And then it wants your degrees of freedom. Degrees of freedom is n minus 1. My n was 12, so minus 1, so it gives me 11. Okay. And if your calculator does not have an infinity button, remember that we would just pick a very large number, so 1e to 99. When I put this all into my calculator, I got 0.0344339. This is actually our p-value. Now in Connect, if you entered 0.034439, it would mark it wrong because they asked you to round to 3 decimal places. So what Connect wants to see to get full credit is 0.034. All right, we have our p-value. Now we need to go ahead and make a decision. So we need to remind ourselves of our decision rule. Our rule is that if our p-value is less than our alpha, that implies we're going to reject. Well, our p-value is 0.034. Our alpha level is 0.10. That was given to us in the problem. And it's true that 0.034 is strictly less than 0.1. So that implies that we reject our null hypothesis. Well, if we reject our null hypothesis, that means we have evidence to support our alternative. Our alternative hypothesis was that the variance is greater than 105. So we now have enough evidence at the alpha 0.1 level to support this claim. So the last step we have is a summary. And in Connect, you don't have to type in the whole thing, just a couple words, but on your midterm and your final, you will have to write out the entire sentence. So what I'm expecting is something similar to there is enough evidence at the alpha equals 0.10 level to support the claim that the variance in grades is greater than 105. All right, I hope that helps. Feel free to email me if you have more questions.